Eric Burgess here, and we've been asked to find the range, variance, and standard deviation, and to use the range rule of thumb to estimate the standard deviation and compare it with the actual standard deviation. And then we're given some numbers here. So this is just some data. It could represent any number of things, average number of hot dogs sold on a particular day, so on and so forth. It's just data. And they want us to do these computations for these statistics using the data. So, okay, looking at this, let's just start off with the range. So the range is equal to the highest value minus the lowest one. So this will give us an idea of, what the span of our data is, how far apart is the highest from the lowest. So our highest value, just looking at this, appears to be 60, and our lowest value looks like it's 12. If you have a lot of numbers, you might consider entering them in the calculator and then sorting them. And it'll actually tell you what the highest and lowest are for free that way, because it can be pretty easy to miss this sometimes. So we're going to do 60 minus 12. This is going to give us, I put equals, minus 12. This is going to give us the range. I'll just put a big R for range. So 60 minus 12 gives us 48. So the range is equal to 48. And that's all you got to do for the range. Up next, we get the variance and the standard deviation. Now, there's two ways to do these. There's the manual way with a calculator and a formula. And there's the calculator method, which does it sort of for you. So I'm going to show you both ways. And then you can use the timestamps to skip to the one that your professor uses. Highly recommend getting to know both, though, because then you can check your work. So let's go ahead and look at this. So first up, we need the formula for variance. So the formula for variance, there are two of them. And I highly recommend writing them out. It's just so you get familiar with them and comfortable with how they look. So the formula is for variance, s squared. I'm going to give you the easier of the two to compute manually, which is n times the sum of all the x's squared added together minus the sum of all the x's, and then you square them after, divided by n times n minus 1. So this is the formula for the variance, and it looks a little intimidating just because we've got a sum of x squared in there, but it's not too bad. And there's a way to speed up doing this with the calculator. So we can actually get these numbers from the calculator for free. And it's a great way to check our work. So I'm going to do it totally manually first. Then I'll show you how to do that. And then I'll show you how to do the calculator. So let's go ahead and make these columns. So we need x squareds and we need x's. I'll put x's first. So our x's are 60, 21, 41, 41, 44, 12, 33, and 50. And our x squareds are going to be 60 squared is 3600, but let's just type it in just to be 100% safe. So 3600, 21 squared is going to give us 441, 41 squared is going to give us 1681, and then that repeats 1681. 44 squared gives us 1936. 12 squared is 144. That's a freebie. 33 squared is 1089. And 50 squared should be 25. I'm writing the answer instead of the whoops. 50 squared, just to verify, is 2500. Yeah, I always will put it in the calculator just because it's super easy to make sort of just a silly mistake. And I really don't want to be guilty of any silly mistakes. So, okay. Let's go ahead and add these together now, because these sums mean to add them. So we're going to add, and when you're doing these, just specifically look at what's in here. So for example, this square is inside the parentheses, which is why we're doing these squares. But this square is outside. So we're going to leave that alone. We're only concerned with the insides. We're going to replace those with their numbers. So doing this, we'll go ahead and add them. So we get 60 plus 21 plus 41 plus 41 plus 44 plus 12 plus 33 plus 50. And we get 302. All right, so at the end we get 302. And at the end of this one, we have 3600 plus 441 plus 1681 plus 1681 plus 1936 plus 144 plus 1089 plus 2500. And we get out 13,072. Beautiful. Now there's a way to get the calculator to do this for you for free. So let's show you how to do that. So we're going to come into stats. We're going to go to calculate or into edit. We're going to go to stats, edit. We're going to choose 1. And I've actually already got the numbers in here. But you'll put all the numbers into list 1. If there's stuff in your lists, just go up to list, hit clear, and then go down. Watch, I'll show you. So let's say we have an 8 here, and we want to clear this list. We go to clear, and then we push down, and we'll clear them. So cool. We've got our list here. So what we can do is we can go to stat, calculate, 1var stats. And when we do that, give it the list that you have. So we're in list 1. So if it doesn't say list 1, hit the blue key, and then in here you can see the lists in blue. So hit list 1. And if there's something right here, go ahead and clear that out. So just hit delete to clear it. And now we're going to go to calculate. So we calculate, and it gives us the sum of x right here. So you can actually skip this entirely. It totally depends on if your professor's okay with this. But you can skip this. This is very easy to make a mistake. So we get 302. And for x squared, the sum of x squared, 1,000 or 13,072, exact same thing. So we have a way to sort of do a sanity check, make sure we got it right. And we even can actually go straight to the standard deviation, which is pretty convenient. So this is going to give us the numbers we need for our formula. The last thing we need is the number of numbers n. So looking at this, we've got 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. So now we can just go right to the formula. So s squared is equal to n, that's 8, times, and I would keep all the parentheses exactly how they are. So that's the sum of x squared. So we found that to be 13,072. Geez, I really don't want to say that number right. Minus the sum of x squared. So the sum of x is 302. So we put parentheses 302, keep the parentheses all the same, put a square on the outside, divided by n times n minus 1. N is 8, and 8 minus 1 is 7. So we can enter this in our calculator now, and we're going to go ahead. I'm going to hit second quit to go to the front page of the calculator. Oh, I'm kind of blocking it a little. And we've got a fraction here, so you can actually type this exactly how it is in this calculator. Just hit the green key and hit F1. And you are brought to this calculator fraction area. We're going to choose option 1, numerator over denominator. And it's going to be 8 times 13072. I recommend saying these things out loud to yourself. It reduces typing errors. 302. Doesn't get rid of them though. And squared over 8 times 7. So I always just want to be a little cautious. So we're just going to double check this. It looks good to me. So you can type it literally exactly how it looks right here. The exact same thing. If you know how to do that fraction move, it's really a game changer because you can do it all at once. And we get a fraction out, but that's no worries. We'll hit the green key and then F1 again and come down to option 4 for fraction to decimal. It'll convert whatever the last thing put in was. So it'll convert this fraction. So we get 238.78. Well, let's round it. Let's make it 79. Okay, cool. So to get the standard deviation, because this is the variance, all we do is take a square root. So the square root of this will give us the variance. So we're going to take second, and then in here on the square key, you can see it in blue, there's a square root. So we're going to choose that. And then we want this number in there. So we can do that. This is in the answer buffer. So we can, if we put answer in, it'll actually put this number there. So we're going to hit the blue key and then go to answer. It'll put the last thing we had right here. We're going to enter, and there you go. So we have 15.45 as our standard deviation. Now this is the results of our calculations by hand. So to do this by the calculator, all you got to do is first make sure you've got your numbers in your list, like we already have. Then we're going to go to calculate one var stats, just like before. Make sure your list is selected and that the frequency list is blank. Hit calculate, and it will give you SX. Look at that. It's right there. 15.45. Exact same thing we got. And if we come down to, or there's no, I don't think it gives you the variance. So you actually have to come in and calculate the variance. So you would take 15.45 and square it. So we can do that. 15.45 and square it. And you get 238.7. And the rounding is a little bit different. And that's because we just didn't include more decimals. The more decimals we include in both will get more accurate. So as you can see, we get the same thing. So we could write like as expected. Got it by the same thing by the calculator. And that's how you do the standard deviation and the variance. And depending on your calculator, some of them actually will give you both in there. I believe the Casio ClassWiz does. And if you have a more recent graphing calculator, I believe they also do that. All right, so moving right along, having done this, let's go ahead and move over. We've got the range, variance, standard deviation. Now they want us to use the range rule of thumb to estimate the standard deviation. So again, let's write out the formula. It's good to get familiar with them. So the range rule of thumb says that the standard deviation can be approximated by taking the range and dividing it by 4. So we already found the range to be 48. And so we're going to take S as approximately 48 divided by 4. This is going to give us 12. So down here we have the actual S, and then we have this S. And they want us to compare them. You could write any number of things for this comparison. You could write, I don't know, the standard deviation, the approximate S is smaller than regular S, or I guess then calculated S. Calculated S. And this is, while this is a comparison, this doesn't really say anything. So we want to say implying less variation than there actually is. Than there actually is. Right? Because if the standard deviation is higher, that means that there's more variation in the data set. If the standard deviation is lower, there's less. For example, if I had a number, let's say we had data points between 5 and 10. If my standard deviation was very low, my data points would all be really close together. If my standard deviation is bigger, they're going to be more spread out. There's more variation. So this one would have a very high standard deviation, where the one before would have a much lower standard deviation, because they don't really move around. There's not as much deviation from the average. That's the other thing. It's also, they're going to deviate from the average. So that is how you would compare these. And when you look at these numbers, sort of what they mean. Now, sometimes it could be useful to do something like this quickly, just to give you a ballpark estimate. Sometimes this number could be wildly different, but it's close enough, often enough, that it can be a useful way to really quick just get a rough estimate of what things are probably like. And that is how you do a question like this. If you have any questions about this question, feel free to drop a comment down below, subscribe and hit that bell icon. If you're a Citrus College student, feel free to stop by online tutoring. We're there to help you out, and we'll catch you in the next problem.